Good evening, all. Good evening, ma'am. It's my pleasure to welcome Honey Joseph, an accomplished professional currently working as a portfolio manager at DXC Technology. With extensive experience leading digital services and application delivery at prestigious organizations like Wipro and Aeroports de Montreal, Honey brings exceptional expertise in cross-functional team leadership and IT service delivery. We are honored to have Honey with us today to share valuable insights and inspire us all. Welcome, ma'am, for the today's session, Software Tools in Safety Engineering, FMEA HAZOP Basic Introduction.
Thank you. Thanks, Deepa. Thanks for the welcome. And thanks, everybody, to be present here. And I'm more excited and to have some time with you all. So let's discuss and explore some topics. I hope you all were receiving some of the sessions last 3 days and excited as well, like me. Or not sure if you're tired after the day work. It's already 6 p.m. there in India. But anyway, I won't make you more trouble to you. So let's start. Let me share my screen. Let me know if you can see my screen.
Yes, ma'am.
Okay. Okay, I see lots of thumbs up. An active audience. That's a good thing. Okay. So let's start. The software tools in safety engineering. I'm not talking more detailedly or many tools, but let's just quickly discuss about the FMEA and HAZOP. I hope that you all have an idea of what's the software tools and what's the safety engineering at least, because the last 3 days you were receiving some of the sessions. And let's jump into the topic. The key points for today. So let's see safety engineering. Why we are focusing on safety engineering? Why it's so important in our day-to-day life, plus in the industries, like all different industry where it is like IT or aerospace, healthcare, marketing, or construction, manufacturing, anywhere. The safety is an important one. It's not one something that addition, but that is a mandatory, very necessary. It's safety first. That's where we hear from our childhood. So safety is an important to save life and have a better satisfaction and business for everybody. So safety engineering, it's a discipline that focuses on preventing accidents and mitigating risk in system or process. So preventing accidents, that's the most important keyword today. So why we are doing it's preventing accidents in everywhere. So that saves life. So it's more important. And how can we achieve this safety engineering? So there are two different ways. So risk analysis and safety management. Risk analysis means how can we identify the risk as early as possible before this accident occur. So accident is always like it's a sudden reaction, but the risk analysis can reduce such accidents. So how can we do risk analysis in different industries? We will look into more detail, but the risk analysis and safety management in industries like IT, aerospace, automotive, I just added few of the industries, but in this applicable in all the industries, wherever you work, wherever you go, wherever you interact in your daily life. And how can we achieve this risk analysis? How can we do this risk analysis? Let's look into that. Overview of key methodologies in safety engineering. That's our topic today, FMEA and HAZOP. I'll go a bit more detail into FMEA and HAZOP in my upcoming slides. But now, why we are talking about software tools? In earlier, we were doing this all the manual methods. How can we identify and all this stuff that takes time, effort, and the result will be very less. But today, we are moving to the digitalization. It's more modern. So everywhere it's digital. Everywhere the system, computer, you go anything from buying a stuff from the shop today until everything you do in your life that is moving to the digitalization. So that's where we live today. That's where we have the software tools in place which helps for our risk analysis, safety management, all together in safety engineering. So our tools help us to prevent accidents, in short. And let's look into what is FMEA. So as I mentioned here, it's failure mode effect analysis. So that's the full form of FMEA. And how can we achieve risk analysis or safety with FMEA? So here I mentioned few points, but let's look into an overview of FMEA. Failure mode and effects analysis. This is more onto a system-based solution. So imagine that you're doing with anything, yeah, a system, and how can we identify the failure modes before we do any action? So there are some steps, there are a process. If we follow that process properly, then it's helpful for us to identify what are the failure modes can occur in that particular system and identify the effects of those failure modes and then implement the solutions upfront so that we can avoid many occurrences in the real life. So what's the definition of FMEA? A systematic method for identifying and evaluating potential failure modes of a product or process and understanding their consequences. So any failure mode will have a consequences. That's where we wanted to identify. So the failure mode will have a bad consequences everywhere, whether it's impacting finance, lives, safety, or anything, but it will have a consequences. So we have to identify the failure modes and their effects. So to avoid the consequences of that failure mode. How can we achieve that? Please do stop me if you have any questions in middle, or if you want to put it in the chat, that's fine. But you can stop me anywhere, no problem. Steps in FMEA. Identify the failure mode. How do we identify the failure modes? For example, what could go wrong? We ask questions to ourselves, or we look into that system, ask questions. What could go wrong with the system? And then evaluate the effects. So if something goes wrong, then what are the consequences of each failure mode? If something fails, what will be the consequences? We can look with an example, but this is how we achieve to that result. And then access the cause. What could this failure occur? Why? Why it's occurring? Like what will be the reason? And then determine likelihood. How likely is the failure? What's the possibility of this occurrence? So how soon, how often? Is it like too often or it's very rare occurrence? That's how we have to ask and identify there. Then prioritize the risk. Use risk priority number, RPN, to prioritize the risk. So I'll say what is RPN and how can we identify the RPN number of every single risk. I'll explain that in the next slide. But implement mitigation, that's the next step. Once we identify the failure, their effects, and the consequences, we come to a number called RPN. That's the risk priority number. And based on that number, we identify what's the priority of that risk. Is that a high, critical, major, or catastrophic, or it's very light? And based on that number, we implement the mitigation. So we are like foreseeing the failure and implementing the mitigation. By that, we can avoid a lot of failure modes plus their consequences. And now we see like what are the some of the software tools for FMEA. So there are a lot in the industry today. So we have some like PTC Windchill or IQRM, then Softstick FMEA. So there are a lot of tools available to implement, but the process behind the steps to follow it's remains same. So what we need to understand is like what is FMEA and how can we implement, and what are some of the advantages of this FMEA software. Like as we said, if we use the software tools, we can do the automates data collection and analysis. When we do automate, it's time saving, error free, and it reduces a lot of manual work. And that gives an accurate result and quick result. So that's why one of the advantage of using software tool there, and then enables collaboration across team. So this action is not performed by a single person. It's a group of people in the industry, whereas in healthcare or aerospace or manufacturing, IT, wherever you are, this action can be performed by a group of people. And this enables the collaboration across teams and then tracks and updates FMEA over the time. So we can track like how many failure modes we have identified and how many mitigations we have implemented over the time. Now let's look into a bit cartoon way because I added this slide as if you have seen the plain slides, it's more boring and me personally I don't like. So let's look into a little cartoonic way like our kids. So failure modes and effect analysis, as I said, it's a risk management tool. So in the failure,
Ma'am, ma'am, the slide has not changed.
I said, now, no?
Ma'am, it's still an introduction to safety engineering.
Okay, so let me stop and present back. Is it visible now?
Yes, ma'am. Yes.
I'm just saying like if it's moving. Okay. Okay, so the failure mode, how could it go wrong? And the severity, how bad that would be. And then the occurrence, the possibility. How often could it happen? Then the detection. Would we know about it in time? Is it possible to detect? Is it easy to detect or it's very hard to detect? And then we calculate the risk priority using an RPN. What I mentioned before, how do we identify RPN? I'll explain that, but that's where we identify the risk priority. And based on the priority, we take the actions from the highest to the lowest. So we identify the risk with the number and then take actions. So let's do with a case study that is more easy for everybody to understand. Let's do a coffee maker. I believe that everybody like coffee or tea for sure. And now let's see a coffee maker. So imagine that this picture, what you see, this is a coffee maker. Everybody's expectation is you go, you press the button, you get the coffee, and very tasty and good coffee. But this system if you do the FMEA analysis for the coffee maker, what will be the impact and how can we identify the failure modes of this coffee maker? And then what kind of mitigations we can implement. So let's do with a case study for better understanding of everybody. Coffee maker, a potential failure mode, the heating element fails. So that is the highest chance. It's not heating, so you don't get a coffee. It should heat on a sufficient temperature and it should pour the sufficient amount of water plus coffee, and then you get a better coffee. So the first failure mode, heating element does not heat water sufficiently. So that's the first failure mode. It can happen. That is one of the options. So we asked the first question, as we said in the previous, we asked what could it go wrong? It can go wrong if it didn't heat properly. That's one of the failure. Then what will be the effects of this failure mode? The coffee cannot be proved. So that's an effect. User frustration and dissatisfaction. So of course, if somebody wants to go for a coffee and get a coffee, but you go there and there is no coffee or it's not working properly, there is a frustration. Imagine that it's in a shopping mall or in an office or somewhere where people really want to get a coffee and go there, and if nothing works, that's a dissatisfaction of the clients and the user frustrations. Of course, that's a bad effect. And then potential for bacterial growth in improperly heated. So if it's not properly heated and you get a coffee coming in, there can be chance of the bacterial growth inside, and that impacts our health. So these all are the potential effect of this particular failure mode. Now let's look into the severity. What's the severity? How serious this failure? We have to put the number from 1 to 10. 1 is the lowest and 10 is being the highest. Let's put how severe it is. In this coffee machine example, that will be one of the severe ones. So probably 10 or 9. That's the severity we can give there. Then assign a score of 9 due to potential health risk and complete product failure. So here we say that there is a potential bacterial growth, there is a chance, so that's impacting health. Based on that, we give the score 9. And then the occurrence. How likely is this failure to happen? Example 1 to 10 again, we give the number. Assume the score is 4, like assuming it's moderately likely to happen. So if there is a chance, it's not that always your system will fail, but there is a chance, a medium or less. So there's a chance. We put the score 4 and then the detection. How easily can this failure be detected before it causes a harm? 5, there is a chance, like we can identify, we can detect, it's in front of us. So 5. Now we look into how we calculate the RPN. RPN is the risk priority number. And we can call SOD, that's a severity, occurrence, and detection. So we say SOD, S into D into S into O into D. So multiply all these three numbers and then we get an RPN number. So severity into occurrence into detection. We say like 9, 4, and 5 equal to 180. So we receive the RPN number 180 that shows your priority number. So imagine that you have 10 different scenarios for this coffee maker. So you get, I don't get a coffee, another failure mode, I get less coffee, or the coffee taste is too bad, not good, it's not sweet. So you can put failure mode or different types and do the same analysis for all those failure modes and do the multiplication. So you do this simple calculation and you get an RPM. You have 10 scenario, you have 10 different numbers. Now let's put it into an order. So which one has the highest number? The highest number is the critical priority. So that's the highest priority, and then which we need to look into the mitigation at the first. So based on this risk number and the RPN number, we identify their priority and then we put the mitigations plan in place. So what's the next step? An RPN of 180 indicates this as a high risk failure. So now we have to implement some actions, mitigation plan. So that's our solution. We put it like upfront solutions. So identify the causes. Why is the preheating element failure? Is it a component failure, the wire connection, or there is an electricity, or the water problem? What is causing the problem? So we identify the cause of that particular failure and then implement an action to that. So propose solution to reduce the RPNs. When we say, okay, replace the element or frequent maintenance, frequent analysis, or you implement something sensor. As we are speaking about the digitalization and we speak about we are moving to the software side and everything, we can add a sensor there, identify if the heating temperature, if not this range, then raise an alert. So it gives an alert, that's an early detection to the system so that a maintenance person can come and check what causing the issue and then resolve. So those kind of mitigation plan we have to implement there. This is just an example of coffee maker, but this is applicable in all the industry. And then we put the solution so the number goes down. Then your chances of occurrence goes down, your severity goes down. So the number goes down, your risk is reduced. So do the same for all the scenario, all the failure mode, and then until you get a very, very, very less risk number and very less chance. So with implementing this solution, what is our outcome? We will have a better solution. We will have a better satisfaction, client satisfaction, and everybody is happy, both business and the client side. Both the side is happy. So we can consider ourselves, we are going to a supermarket. We wanted to buy something and the cashier says, oh, the system is broke. That we might be in a rush, we have to go back quickly, or etc. etc. We will be in frustration mode for sure. So if everything's work fine, if that person would have been implemented mitigations plan, okay, if this cash counter is failed, I have another option. Or if this ATM machine doesn't work, I have another option. So if we have mitigations plan in place, both sides will be happy. That's why I'm saying, so it's implemented and applicable in all our day-to-day life. Then finally, what we have to do in this process, we have to rescore. After you implement the solution and mitigation plan, do the same activity, reevaluate, and then rescore. So that's how we can achieve to a better solution. This is how we put FMEA in place in any industry. So when it comes to healthcare, it's more health related. We have to implement the solution. So when we say FMEA, it's more into the system based. A system, how can it go? How can it fail? That's what we think and put as solutions. Do you get some idea what's FMEA? And how do we calculate the risk priority number? How can we implement a mitigation? Anybody understood? A thumbs up? No? No thumbs up? Are you guys listening? Okay, cool. At least one. Okay, there are few. Okay, cool. So that's how we can look into more details, but now let's see what are the advantages of FMEA. Some of the advantages we already spoke about, but one, avoidance of potential failure. So coffee maker, you may feel simple, But imagine that it's a mining industry, the people are going under and it's mining going on, and there is a catastrophic failure that cause a problem in many lives. But if we implement some such detection process and implement a mitigation plan, we can avoid a lot of risk in there. Same like that in manufacturing or a construction, anywhere, aerospace. Now it's the travel and everywhere it's increased. So in all critical industry, if we implement, we can avoid potential failures. And now we look into the second advantage, that's increased functional safety and reliability. What is reliability? When we say reliable, what is reliability? That says that if one system failed for some reason, can we rely on another? So in IT, we call it high available. So imagine that you have two systems. As you all, I think you all are working in the college and that side. So you have two systems and you relay some data from one particular system. And imagine that system crashed or shut down for some reason. And you need an important data from there. So what you will do if that system crash? That's where we have like high availability in place. So we have the same copy of the data in another system and we configure like, okay, if this system fail, retrieve the data from another system so that the person who is in the other side, who is trying to retrieve the data, they won't get affected even if the system crash. So that we say like reliability or high availability. And we say that functional reliability, that's an advantage here. By implementing solutions and mitigations plan, we give a more reliable and safety solution to the client, to the customer. And when I speak more about the client or customers, it's not only benefiting the clients or the customer, it's also benefiting the business. Imagine that you identify and detect, you implement a solution that is less cost than you identify an accident or a failure after it occurred. So you may have to replace the whole solution or you may have to replace the entire equipment. You will have to spend more time, more costs, everything. So at the time, it impacts your reputation. And this helps in both the side, both business side and the client side. So in industry, this is very, very important. So it gives a safety and reliable solution. Now, the third advantage of FMEA, it's a robust design and stable process. So somewhere we have seen like whatever we do, it will never fail. And everybody says, yes, that's a good phone. Or for example, oh, that's a good phone. It won't break easily. Or that's a good laptop. That's got something we use in our day-to-day life. Why we say that is a good one? Because after people using that, they feel it's not breaking easily, it's not crashing down easily, it's a robust solution, it's strong, and it never fails or a very less chance of failure. And if we need to hear that, the reason behind is people might have implemented all this risk analysis and mitigation plan in place and do a continuous thorough monitoring and maintenance in place to provide you a robust solution. And the fourth one is cost reduction. As I said, it's reducing the cost for the business side plus the client side, both the place. So you get cost reduction. And even in industry, if you identify the solution upfront and you try to mitigate, you can reduce the cost. You don't need to replace or you don't need to go for, imagine that there is a worker and that worker got an accident. As per the company rules and regulations, you will have to pay the treatment cost and the disability help, and then all this you need to provide, plus that person's life is in danger or he is in like severely injured and all those stuff. So the cost reduction is applicable and possible if we do this process and identify the risk upfront. And then the legal protection. So this is somewhere related to the example I said before. A person got an injury, they can sue the company or they didn't provide the safety requirement upfront. That's the reason of my accident. This goes a legal action against the company. In mainly in industries, this can cause a lot of problem. And if you have a legal case against your company, it's your reputation. There are a lot of headaches you have to. So you can avoid all such legal stuff and it gives you a legal protection. You say that I have implemented all this solution upfront and I have this certificate. I am legally protected in all these cases. And operational efficiency. Operational efficiency is providing a better service and the user get a better satisfaction. So that's where we say operational efficiency. We have to monitor, provide a better service, better solution, and better output. So everybody is satisfied. That's the operational excellence. We get or give the best of our product or service. And then seventh one is the communication improvement. So if we have proper solution in place, our communication is better now. We can provide an update to the clients. Okay, if this happens, please do this. Okay, if this occur, this is the solution. As we identified the cause and the mitigation upfront, we can provide a proper communication. We can provide better service to the people and in the industry. And then knowledge-based development. So this is as soon as we identify some cases, we are acquiring more knowledge on that particular area. So the more we think, the more we speak, the more we look into the issues, that we get a lot of knowledge and we update our knowledge base. So this helps if in case if tomorrow somebody is going out of that industry who implemented that solution, but there is a proper knowledge base available, then somebody else coming in that place can take over very easily because everything is documented, knowledgeable. It's very easy. And this is also an important point and as an advantage of FMEA because FMEA gives a track that you'll have all scenario, what were the initial occurrence, what were the initial severity, and after you implement some solutions, now where are we? Now what's the severities? All these are tracked in an FMEA report. So that gives like, okay, this is all already implemented. These are some of the advantages of FMEA. Now let's conclude the FMEA and we have to look into another topic. So as I said, FMEA is an excellent tool for improving safety because it's proactive. That is more important, proactive. Everybody wanted to be proactive in today's life. Why proactive? Because we identify the issues proactively before it occurs. After it occurred, then we give a solution. That is not a good option. So be proactive and systematic. That is the advantage of this tool again. And then, as I said, instead of reacting after it occurred the failure, we identify and prevent the problem upfront. So that's the advantage of FMEA. And why do we need to use FMEA? It's more safe, reliable, and high quality product. That's what everybody wants. Wherever you go, whatever you buy, whatever service you're looking for, you need a safe, reliable, and high quality product and service. We can achieve these by implementing this FMEA solution in place. And please remember in mind, it's how do we identify the RPN? It's severity into occurrence into detection. So S into O into D is called RPN. That's the risk number. Based on the priority, implement the solution. That's in short. Okay, so anybody has any question on FMEA? If not, then we'll move to another topic, that is HAZOP, but I'll give you a few seconds if anybody has any question. All good? Okay. Let's look into the next topic, HAZOP. What is HAZOP? Anybody know what is HAZOP? Or you are hearing first time for HAZOP? HAZOP is Hazard and Operability Study. So that's the short. It's HAC, it's Hazard and Operability. That's HAZOP study. And who implemented and why this study came in picture? So little background of this study. It started in UK that many industries were having an impact. They were like their workers, millions of life were getting in danger. And these industries came together and discussed how can we avoid such accidents or injuries, especially for our workers, and give a better workplace environment for everybody. And then the team discussed the industry representative. They spoke about it. They were coming up a solution. That's where they named it as like HAZOP and operability study. This is more on the process oriented study. The one we saw earlier, FMEA, was more on the system oriented because we look into the system and how can it fail. That's what we were looking into. Once the system is in place, what are the possibility, what are the occurrence, or how it could fail. That is on the FMEA side. But for HAZOP, we look into the process. Like what is the process of this solution? And then how can we identify the consequences of that process and the deviation of that process? If there is a process deviation, what will be the consequences? It's more on the process-oriented solution. So let's look into an overview of HAZOP, Hazard and Operability Study. It's a structured and systematic technique for identifying potential hazards in complex and evaluating their operability. So this solution is more implemented in industries like very critical industries, chemical industries or laboratories, where you have like more critical actions in place which can cause accidents or more severe critical problems to human life. Those industries, it's mainly used in the chemical side because the reaction to the chemical reaction is more dangerous to us. It's against the human body. It can happen anything like coronavirus. The study says that some chemical action, it's not proven yet, but some study says some chemical action, some cause, some biological chemical test which cause this virus. So anything can happen. It is very difficult to stop or control if something occurred. So all those kind of complex and critical industries, we use the hazard method. And let's look into the step, how can we implement the HAZOPs? Identify the deviation. So imagine that there is a process. That process should follow this, but if there is a deviation to that process, what will happen? What is the cause of that deviation? Let's look into that. Then determine the cause of deviation. What could cause this deviation? So imagine that it should flow in particular way, but there is a deviation. And why that deviation occur? What is the cause of that deviation? Then access the consequences. if that deviation occurred, if there is a cause, then what's the consequences? What can happen? What will be the output of that deviation? And then we look into the recommend corrective action. How can we mitigate that risk? So both the solution, FMEA and HAZOP, both are risk analysis techniques, as I said. So again, we identify a risk here using HAZOP, and then how can we mitigate that risk? These are the primary steps in HAZOP. And again, as our topics, it's software tools for HAZOP. In the industry, there are a lot of software tools available to implement or to have the solution in place. But the process behind HAZOP, it remains same even if you are using any tools. It's like hazard and operability study tool. There is a tool called HAZOP Plus. So we can use that. It's more than you take a pen and paper and you do a study, you write it and then think about it. It takes time. Then you use the software tool HAZOP. You put it in the laptop, phone, your system, and then enter the values, chances of occurrence, and then remaining the system will do. So it's more quick, easy, reliable solution. So HAZOP Plus, and then the PHA Pro, that's the process hazard analysis software where we can use. And then LOPA, layer of protection analysis tool, that is one another, and PHA Works. This is all some of the tools available in the industry today for HAZOP analysis. And what do you think that the companies spend a lot of amount and money in all these studies and buying the software tools and implement? Because it gives advantage. It has a lot of advantage. It avoid accidents. It helps a better solution, operational excellence. It reduces the cost. Even if you implement something, it's like we are taking insurance. Why do we take health insurance? Why it is important? We get some illness and then we spend lot and lakhs of amount in the hospital. Then you pay some amount in the insurance. I'm not I'm not saying the advantages of health insurance here, but that's an example in our daily life. You put some amount upfront and then you have a solution in place. So you don't need to worry if something happened. Of course, it's not good if something happened, but again, you don't need to struggle at that particular moment because you may not be able to work at that moment. You will not have an income at that moment. You will not have helping hands during that moment. So you have a plan in place already. So it seems like that. The companies are investing in all these tools and solutions and taking time to perform all the studies and identifying the risk so that they get a better solution, they get a better product, they'll have a better operational excellence. That is the output and result of all this implementation. And what are some of the advantages of HAZOP software? It simplifies and organizes the complex HAZOP session. So imagine there is a factory with a lot of instruments, chemical thing, and then you do a study, you do a HAZOP study in that. If you start writing on the paper and look into the board and etc., that's more complex. It's hard to track and then hard to provide a solution or identify the risk. Instead, if you use a software, your system will do half of your job. You just need to enter the data. You will only need to do a data entry person or data entry work, and the remaining system will do. So that's it simplifies and organize, even though it's a complex session, and then facilitate better documentation and traceability. So you get a solution and you get a report. After 2 days, you wanted to see like, oh, what was the outcome of the first session, first HAZOP study? Just go back, click 2 button, you get a report. So it's more quick and traceable, helps in scenario-based simulations and impact assessment. So you put a scenario, you say that, okay, this is one solution, one chance. I need an output of this. You don't need to spend another day to put that scenario and identify the risk. You just give the solutions and the scenarios to the system. The software gives you the output. Those are some of the advantage. And as we look into the coffee maker before, let's look into another case study in the chemical industry. As I said, it's mostly commonly used method in chemical industry. So a simplified HAZOP example in chemical industry. Imagine that you take a two test tube. You want to mix two chemical solution and get a third solution. So let's put a name like chemical 1 or chemical A and chemical B. You want to get a chemical C. That is the simplest chemical action in the industry. So there are some guide words in HAZOP. So we say no, more, or less. Those are like some guide words with the process. So in the chemical industry, if we look into that, do we need to pour more? The chemical A and B, which we need more and which we need less. So those are some of the guide words we use in the HAZOP with the process parameters such as flow and temperature, asking what if there is no flow of chemical A? What will happen? So as we said, HAZOP is a process oriented, and we have a process. Chemical A should be 50 ml, chemical B should be 20 ml, and mix at this temperature, and then you'll get a solution, chemical C. What if there is no flow of chemical A? You just get chemical B for 20 ml, and then you heat it up. It will have a reverse result. So we identify, we take a deviation of that process and think for like what will be the consequences. And then we have to see what is the cause of that deviation. Why there is no flow in the chemical. Let's look into an examples. So systems A, simple vessel where chemical A and B were mixed to form a product C. So it's like product A. Chemical A and chemical B we are putting here, and the nodes. So node is a chemical feed line or a mixing vessel. So there will be a line, there will be a mark that you should have until here or pour until here. That is the line. And we say that there is no solution from chemical A, then what will happen? So select the parameter, the flow, the process parameter, flow, temperature, level, pressure, and composition. Again, we use the same guide words like no, more, less, like part of, and then we say, okay, there is a problem in the first flow, which is causing the deviation. And then we have to analyze each node. So we say mixing vessel is a different node. So chemical A, chemical B, there is a vessel and there is a node and a temperature. We say this temperature is more. So what will happen if the temperature is more than usual? We all might have did simple experiments in our chemical lab in our schools. So we have seen that if the temperature goes little high, the test tube breaks, it pour in your hand. If something acidic, it's dangerous to your hand, your health. You smell that, and then you inhale that. It spread across the lab, the area. This is all problems, right? So that's the question. Like, what if the temperature is more than normal? Then possible cause: overheating from poor temperature control or runaway reaction, All these are the possible cause of the temperature. Then what's the possible consequences? Decomposition. Okay. Decomposition of the product, vessel, or over pressurization. That are some of the consequences of this cause. Then what's the safeguard? Like how can we mitigate again? If that cause, how can we mitigate? Let's implement some sensors, temperature sensor, cooling jacket, or emergency vent. So you check a temperature sensor, and if it's not it's not getting heated up to that level, or it's more getting heated, then you alert. You get a sensor, so that before the cause or the impact occurred, you'll get an alert. You can stop the accident there. And the recommendation is verify the effectiveness of cooling system or a sensor, and then you install the alarm system. So this is how you implement some mitigation plan. You can avoid that catastrophic accident in the real life and in the industries to avoid some such risk. Same like that, we can continue with all other parameters like flow A and B, etc. We implement the solution. I'm not going every single parameter, but this is how we do the HAZOP study. And then finally, we have to record all documented deviation cause and then existing safeguards, the recommended actions. That's how we move forward or we implement the solution. This is the documentation of our findings and then solution implemented. So you have to continue with all the parameter, the same study, and come back to the solution. Now let's see the comparison between FMEA and HAZOP. So FMEA, as we said, it's more failure mode analysis. It's system related, how it go, how can it fail, but HAZOP is more on the operability. It's like how that is operating. What can be the deviation to that process? So one is system-based, another one is process-based. One is on the failure mode analysis, another one is an operability analysis. But both are possible. There are some industries where FMEA is more being used, and some industries where HAZOP is more being used. But there are some industries, both the solutions are being used to get a better risk analysis. If you all want to implement this, please think about an ATM operations. Here, if we implement in FMEA, that we have to think about an ATM machine, because every single person, I'm sure whoever there in this call might have gone to ATM for sure. So it's more easy and simple solution. If we look into the FMEA study for an ATM operation, we have to think about how can an ATM fail. So there can be a card jam or a money jam. It's getting stuck. The display goes wrong. It's not detecting your card. There is no money, which is causing problems. So all these solutions or all these failure modes are applicable in an ATM. So we think about what all situation can ATM fail, and whereas you think about HAZOP, you have to look into the process. So the process of an ATM, in simple way, you put your card, the system reads your card, identify who you are, then it communicates with the bank, identify your account, your money in that, whether it's a withdrawal or disposal. So the system has to identify your account, do the calculation, do the transaction, approve the transaction, provide the result, where it's get deposited or a withdrawal. So that's the process. And the HAZOP implement study on that process. What if the card didn't read properly? What happened if it couldn't read you, or it didn't communicate with the bank? So it didn't communicate with the bank. And in the HAZOP study, we have to say, if it didn't communicate with the bank, what can be the cause? Is there a network problem? Is the bank system down? And then what will be the consequences? If it didn't communicate with the bank and didn't identify you are the one, then it misread the card. It may not give you the money. So there can be causes. And what are some mitigation plan in both the cases? Here in FMEA, we can put mitigations that raise an alert if there is a jam, if there is a money jam there, or if your card getting stuck there, raise an alert so that a security or person can come and verify, or it will not give you back your card, or it will give you back, it will not complete your transaction, etc. Those kind of mitigation plan are here in the process. Then your bank get an alert saying that, oh, somebody trying to get an amount in this card. There is a solution. So as a mitigation plan, you can display on the screen that there is a technical issue going on. Please wait 5 minutes, or please visit another branch, another ATM, etc. So those kind of mitigations plan, or you can have a regular maintenance, like every week there is a maintenance. If it's very busy ATM, then every day there is a regular maintenance. You verify the connectivity, you verify the internet and all those stuff. So those kind of maintenance can also avoid some issues. And as it's impacting the transaction, it also avoid the theft and the loss of money and the customer satisfaction. And roles of software tools in safety engineering. We have seen some of the advantages already, but I'll quickly put it in place some of the points. Some improved accuracy. So if any human doing any activity, there is a chance of human error. That's possible because we are humans, we are not computers. There is a chance, but if we use the software, minimized human error in risk analysis. So that's an advantage. And then efficiency. Automation speed up the identification of failure mode. So the quick result. If you have 10 people putting in place and doing this solution, you can get the same result in 1 day if you're using a software tool. That's the efficiency. And then collaboration. So you'll have a centralized platform. Else, if you are doing that 2 HAZOP study, you'll have one team and another team. Then you'll have to get a report from this team and another team. But if you're using a technology or the tool, you get the centralized platform to work together, identify the risk. You can get a report, you can prioritize the risk quickly and easily. Then regulatory compliance. So you will have to follow all the compliance as there are audits in everywhere. So you have to make sure that your solution is compliant. And then the data management enables easier tracking, reporting, and auditing. Those are some of the advantages. And now we have like a lot of cloud-based solution. You all might have heard about all cloud solution like AWS, which provides by Amazon, and then Microsoft Azure provide by Microsoft, and then Google, the GCP that's provided by Google Cloud Platform. All these cloud platforms also provide solutions for all the study and the risk analysis. So which shows the importance of risk analysis and importance of putting it in place in different industries. And I put some pics here. So that are some simple safety tools in our day-to-day life. If you just sit and look around or you walk around, you can see a lot of safety tools already put it in place around us. CCTV. Today in most of the houses and the buildings, offices, institutions, they have cameras. Why? Because we put it as a safety requirement. And the doorbell camera, we can just sit in our place and see like who came in front of our door. That easy. Like if somebody unwelcoming, if some theft, something, you don't need to open the door. There are cases in India like we heard about, or you open the door, some thieves like they hit on your head and then you get all these problems. So but if you have a doorbell camera, you don't need to open the door if the person is unknown. You can see what's happening in front of your door. These are some of the tools. It's the improvement and solutions of digitalizations. How can we utilize in our day-to-day life? What are some tools we use? And this is the license plate reader. This is used in most of the places these days. Now we have on the roads that it reads your number plate. If you're overspeed or if you do something, that you get a ticket to your house. And how that is possible? It's another solution of digitalization and the software tools. And this is again a safety because the overspeed is dangerous. It causes accident. So to create a safety, to make sure that people are going secure and safe, we implement all this solution. And this is quick and easy because of our software tools, the digitalization. So thanks to all these tools, which makes our life easier. And here are some sensors. We talked about sensors in previous slide, how the sensors work. We have street lights or we have lights around our courtyard or around the houses and etc. But we don't need to turn on these lights every minute. That have higher consumption of electricity and that gives like a bill, electric bill, but we can implement a sensor. It's a motion and light detection sensor. So if there is a movement in that area, automatically turn on the light. I think this is now implemented almost all the places. But these are some simple safety tools and the advantages of digitalization in today's life, where we are seeing without even noticing. We are not maybe thinking about all this, but these are all some of the tools which we are using in our daily life. And as I mentioned previously, this is like wherever we can use in which industry, which method is beneficial. FMEA it's better in automotive industry, and as I said, HAZOP is good in chemical industry, whereas in aerospace and other industries we use both. That gives a more robust and a better risk analysis. So if we can use both and get a better risk analysis. Now let's see like best practices using the software tools. If we are using any software, we have to do some training before to understand like how that software is being used and the data consistency, because as good as like it's helping us, there is a disadvantages too, like if you're not using it properly. So proper knowledge, how do we use that software is very, very important. And data consistency. So the system reacts based on what data you put it. These days, like I've seen this trend in the Gemini, that everybody puts a photo and then you get a very nice edited photo. Most of you might have already tried, but there is an advantages and disadvantages. Advantage is like you get a better photo. You might not even have like seen how beautiful you are if you are in that kind of dress or or in that particular area, if you have a such background, etc. So you get better picture of yourself. But the disadvantage, you are giving your photo, that's an identity, your identity, to the internet. Nobody knows where it goes. Nobody knows what is the risk behind that. So that is the disadvantages. It's a risk. You give yourself, your photo, your identity to a cloud. It can misuse anywhere. Nobody knows like where it goes. It never gets deleted. Anything goes to internet, it never ever gets deleted. So that's the disadvantage. Same like that. All software tool, we have a lot of advantage, but we have to use very, very, very careful, else we can get problems. You all might have heard about a lot of spams happening across the world. Why? Because it's all some loopholes of the software tools. There are, because all this written in a code, it's a logic, it's computer, it's a human input after all. There will be a loophole somewhere. So somebody find a loophole and try to trap you, spam you. A better understanding of the tool is always important, and the data consistency, like how good data you put it into that system or you give to that system, that better output you'll get from the software tool. And the regular update. So why regular update is necessary? You might have heard about vulnerability, software issues, risk, and all this. Like why we say vulnerable? The software is vulnerable. All the softwares are written in some technology like called Java or Python and all this tools. Every technology needs an upgrade, or the servers behind. You use any server, you need to upgrade that. You have to get security patches, implement updates, and do the maintenance. All tools, maintenance is necessary to have or to avoid attacks, cyber security. So that is an important, we will talk more into the next session, but regular updates is necessary for any software tool. Same like we update our phone, like that is also necessary to get more up-to-date feature and security measures. As I said, the training, that's another thing. Anybody who use the tool should have a proper training. How can we use this tool better? Else it may cause another problem without knowledge if we use any software tool. And the documentation. Keep detailed records of all analysis. That is also a best practice if you are using the software tool. And what are the future trends? Today we are in digitalization, but future, where are we going? So we go to AI and machine learning. Artificial intelligence is now, it's a booming factor. Everywhere the companies and the industries think about artificial intelligence. Google Gemini, everybody is using now. What is it? It's an artificial intelligence. Chat GPT. If any answer, anything you want, you just go and type it in the Chat GPT. What is it? It's an AI. So AI makes our life easier, but as I said, it's dangerous too. So we use for better output, better solution. We don't misuse anything and be careful like what we use. As I mentioned before, anything we put it into the internet, it never deletes, never ever. Anything can be used by any company. There are hackers, they get data, and we don't even know, like all these big companies, they sell our data to where, which company, to who. It seems like we get phone calls from different places like, oh ma'am, do you have an offer? We have an offer. Do you like to hear something? How they get our phone number? We go to a shopping mall, we buy something, and first thing they ask these days like, Can I have your phone number? Why do they need our phone number to buy a cloth from a shop? That's marketing. So they get our phone number. They sell our data to another company. They use for something. So they get your phone number. Another company gets it. Another entity gets it. They give you a call. So we have an offer. If they call 100 people and if they get 10, that's an advantage. So anywhere we use, we should be very careful, even it's AI or machine learning. It's helpful for us. If you have not used, use ChatGPT and Gemini and all these tools for your learning purpose and anything. If you want to create, you need to know anything, use it. It's very good, but use it carefully. That's the only advice I give you. And automation, using automation to suggest mitigation strategy. So automation is another booming one in today. Cloud collaboration everywhere, every industry, every system moving to cloud. No more people wants to on-premises servers, systems, and we store our data, and it causes problem. Like if it crash everything, we lose all our data. Instead, we give it to cloud. One or the other way we can retrieve it. It never gets deleted. And it's more reliable, high available, and robust solution. And IoT, Internet of Things. So it's IoT integration is also another major trend. So let's conclude. I think people are getting bored. So let's conclude. Software tools significantly enhance the efficiency and accuracy of FMEA HAZOP process. So it's not only on this process, but everywhere software tools helps it enhance. And these tools help engineers and safety professionals to assess the risk and put a mitigation plan in place. And the use of more modern technologies like AI and IoT machine learning, it gives an advanced safety engineering practices. So that's my conclusion for today. I come to end of this today's session. Thanks for listening me all this while after your day work, but any question?
Okay, ma'am. Thanks for your wonderful section. It's time to ask queries. If anyone have any doubt, just clear it.
Either it's more clear or you didn't understand anything. That's the two chances of not having questions. Okay, no worries. Why does safety engineering means? Let me go to my first. So this was my starting. Hold on. Give me a minute, I'm resharing my screen. I wanted to show you, that's why. Sometimes the system is stuck too. Anyway, I wanted to show you my first slide because I start with that, but it's not moving. So let me explain. So safety engineering, why we need to implement safety? That's the answer. So safety is an important aspect in our industry, and why we have to implement that engineering means how can we identify the risk in proactively and implement a solution. So how can we achieve that? What is the engineering process to achieve safety behind? That's called safety engineering. It's a multidisciplinary action for identifying the risk proactively and implementing the mitigation plan. So that's a safety engineering. And how can we implement that safety engineering? How can we achieve that safety engineering? Those were the two topics I covered today using FMEA and HAZOP. But it's, in short, it's identifying the risk proactively and mitigating the risk proactively to have a robust, safe, and reliable solution. Is it clear now? Thank you. Any other question? If not, then let's take a break. Deepa, when we start our next session in, ideally it's supposed to start at 9.
Ma'am, let's start a new section by 7:45.
Okay, so 7:45 my time, it's 10:59. Okay. Okay, so it's supposed to start 7:30, but since we finished just it's 4 more minutes, let's take a break and then come back by 7:40. Why FMEA is called bottom-up analysis while HAZOP is top-down analysis. FMEA is more on system failure analysis and HAZOP is process consequences analysis. So we don't say it's bottom-wise or top-down, but we look into the failure mode of a system in FMEA and a process consequences in HAZOP. It's not that, okay, you should use this, but these are two technologies and studies available and two process available based on your industry and your system. You can choose one or both to identify the risk. So these are two just solutions. What is the most critical failure mode identified? This depends on where you implement the solution. So imagine that you are implementing it in a healthcare. What will be the most critical failure? A death of a human, a death of a patient. So that will be the most critical. But if you are implementing this study in a mining industry, you get a crash in the mining area, your worker's life is in danger. That will be the most critical failure mode of that industry. So it's based on where you implement this process. What is your industry? What is your solution? And what is the fatal thing can happen in that solution? So we say most critical, all based on your industry and the solution. And in aerospace, if you say an example, what can be the most critical? A plane crash. That's the most critical. Whereas in the simple example, when we talk about coffee maker, you don't get coffee. That's most critical. Your solution is simple, so your failure mode is simple. But if your solution is critical, your failure mode critical too. In an airport, plane crash is the most critical failure mode. So I hope that clarifies your question. Thank you. Anybody else? If no, okay, let's wind up. Thanks, everybody. Thanks for be patient and listening me all this while. And see you in 15 minutes.